So we've already talked about just box plots and line plots on their own, but what we're going to focus on for this last lesson of the unit is double box plots and double line plots. So we use these to easily compare two sets of similar discrete quantitative data. So for example, if you have the data from two different subgroups about the same thing, so the heights of 6th graders versus the heights of 8th graders, the salary of women versus the salary of men. So two different but similar things that we can compare easily on a graph. So let's look at this first example. Ms. Cripinger wanted to analyze the commute times on buses versus cars to pick the best route. Create a double box plot for the data. So with our box plots, we need to put these in order. So I'm going to do the bus first. Our lowest value is 12. 14 and 15, 16, 16, 18, 18, 22, 25, and 28. Let's double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So, going to cross off, lowest, highest, lowest, highest, lowest, highest, lowest, highest. We get two values in the middle here. So the median is 17. Then, for our Q1, crossing off, lowest, highest, lowest, highest. We get one value there for our Q1. For the top half, lowest, highest, lowest, highest. We get one value there for the Q3. Now for the cars, I'm going to put those in order. So we've got 8 and 9, 10 and 10, 11 and 11, 12, 13, 14, and 17. I should have 10 values. I'm going to double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to find my values for this. Crossing off, lowest, highest, lowest, highest, lowest, highest. I get two values in the middle, but they are the same. So our median's 11. Finding our Q1, lowest, highest, lowest, highest. We get one value there. Finding our Q3, lowest, highest, lowest, highest. We get one value here. So I'm going to plot these values. Doesn't really matter which one I start with. Let's say I plot the car first. Okay? So again, we plot our lower extreme of 8. We plot our Q1 of 10. We plot our median of 11. We plot our Q3 of 13. And we plot our upper extreme of 17. The Q1 and the Q3 are the sides of our box. We draw a line, a vertical line down where the median is, and then we connect our lower extreme and our upper extreme to the box with a horizontal line. I'm going to label right here that this is representing the car, just so that we know. Then I'm going to do the bus. Our lower extreme is 12. Q1 is 15. Our median is 17. Our Q3 is 22. And our upper extreme is 28. So again, our Q1 and our Q3 are the sides of the box. Connect. To make the box, draw a vertical line down the median, and then connect our lower extreme and our upper extreme with a horizontal line. And I'm going to label this bus. Okay. So the reason that these are nice is it's pretty easy to compare that. Like, you can look at this right away and say, okay, yeah, not every single bus ride is longer than the cars because there's overlap here. But generally speaking, it's going to be longer if you're taking the bus, right? And that data's a lot more spread out than this. This box plot is only this long. The bus is much longer. So let's look at actually analyzing these. The height of girls versus boys in Mr. Sapraga's gym class are shown in the double box plot below. Use it to answer the following questions. The girls' heights were taller, on average, than the boys' heights. So, the girls, were the values generally speaking higher than the boys' values? No. Some of them were, but generally the boys were. So, that is a false statement. The boys' heights were taller on average than the girls' heights. Yeah, most of the boys' heights, generally speaking, are higher than the girls, so that is true. The boys' heights vary noticeably more than the girls' heights. So what I would really look at here is there's going to be some parts that are different, but overall, how big this box plot is compared to this box plot. Even if we look at like our IQR, which would be from here to here, 63 to 68 is 5. From here, 68 to 72 is 4. Is that really that much different? Or the range, 61 to 69 is 8. Here, 66 to 74 is 8. They're pretty much the same, right? So they don't really vary that much more. That is a false statement. And then the median height for the boys is 5 inches more than the median height for the girls. So our median height for the girls is 65.5. The median height for the boys is 69 inches. Is that a difference of 5 inches? No, that is a false statement. All right, number 3, a dot plot here. The top 8 finishers in the semifinal and final rounds of the 100-meter backstroke Olympic event are shown in the dot plot below. The swimmers had slower times on average in the semifinal round. So we're looking at this. The semifinal. Were they slower times? So we got to think about this. Slower times are actually higher values, right? If you're taking longer to finish, that is a slower time. So it's work in the reverse here. Be careful when you're looking at that. So the semifinals here versus the finals, I would say majority of these semifinal times are lower than the majority of the finals. So I would say that is a true statement. For B, the swimmers' times vary noticeably more in the finals round. Well, let's look. The range in the finals round is this wide versus the range, and this one's kind of separate, is much smaller in the semifinals. So I would say, yeah, they do vary noticeably more in the finals. Not as clustered together. C, all of the times in the semifinals are faster than the times in the finals. So is every single time of the semifinals faster than the finals? No, that is a false statement. The mean of the semifinals is 0.4 seconds longer than the mean of the finals. Well, that means that we actually need to calculate. So let's do the finals and the semifinals. Let's do semifinals here, and let's do finals here. So we got to be careful. Each tick mark is representing 1/10, okay? So when I'm calculating the finals here, this is 56 plus 56.6 plus 56.6 plus 57 plus 57.1 plus 57.2 plus 57.7 plus 57.9. So we get 456.1 divided by, there's 1, 2, 3, 4, 5, 6, 7, 8 people. So that's 57.0125. I'm not going to round yet, just to make sure. Let's look at the semifinals then. So we're adding 56.7 plus 57.2 plus 57.3 plus 57.3 plus 57.4 plus 57.5 plus 57.7 plus 57.8, which equals 458 and 9/10 divided by 8 people equals 57.3625. So, if we're looking at tenths, this is about 50. So if we subtracted 57.3625 minus 57.0125, we get about 0.35, which if we rounded that would be about 0.5. So was it 0.4 seconds longer than the mean of the finals? Let's say, yeah, took them that much longer. All right, one more set of analyzing. The double dot plot below shows the number of hours a class of students exercises each week to the number of hours the students play video games each week. So the students on average exercise more than they played video games. So there's lower numbers for the exercise, there's higher hours for the video games, so no, they did not exercise more. The exercise times vary noticeably more than the video games. So if we look at this, we've got, a big cluster here and then some kind of spread out there, versus the video games, they seem to be a little bit more spread out. So the exercise times vary noticeably more. I'd say probably not. All of the video games times are more than the exercise time. Is every single value here higher than the exercise? No. And then the median of the video games is 4.5 more than the median of exercise. So you could write these out in order if you want, or we can just cross off lowest, highest, lowest, highest, lowest, highest, lowest, highest, lowest, highest, lowest, highest. Our two middle values are 2 and 3. So that means the median is 2.5. Same thing for our video games. Lowest, highest, lowest, highest, lowest, highest, lowest, highest, lowest, highest, lowest, highest. The two values in the middle are the same, which is 9. So the median of the video games is 4.5 more than the median of exercise. Well, 9 minus 2.5, whoopsies, is 6.5, not 4.5, so that is false. So the nice thing about dot plots and line plots is you can it's already in order for you, so you can cross it off that way. If it's easier for you to list out 0, 1, 1, 1, and so on, and cross off that way, that's totally fine too.